Awesome sauce. Start the stream. And a few more on Zoom to check in. Jasmine and Naomi. And down here somewhere. Okay, so I don't see Noe and I don't see Michelle, Ashley, or Christopher. Okay. If I marked anybody absent, they'll yell at me. All right, good morning, everybody. Come on, we got a decent sized group. We can do better than one voice, right? Good morning, everybody. Oh, that's better. All right. You don't have to be the brightest to be big and strong, right? But you do got to be something. Okay? That's going to be my emphasis, right? Best steel doesn't mean you have to be the brightest. Maybe you can be the strongest, the toughest, or the most flexible, actually. Steel is very bendy when it needs to be. Today, we are going over your unit review. I'm going to walk you through the answers here, give you an opportunity to ask questions. That'll predominantly fill the time in preparation for our coming test that will take place on both Wednesday and Friday. I've divided it up into two sections. So the writing portion that very much resembles these last couple questions. And when I say very much resemble, I mean like almost exactly. You'll have a question just like this, asking you to explain a thing. You'll have a question just like this, asking you to write out the argument and justify it, aka a 2-column proof, okay? That'll be what you do tomorrow in class, which means I need everybody to tune in to the Zoom tomorrow for class time because it's a timed test. At the beginning of the class period, I will then post the link to the document. You can then type up your answers, submit on Google Classroom as you do with any other assignment before the due date, which will have the time set as the end of the class period. Okay? Today is the day before your final chance to let me know, hey, wait a minute, I've got a doctor's appointment or a dentist or something scheduled for that day, or this other teacher needs me to be in class for that. Let me know now so we can make arrangements and I won't mark points off for turning it in late, okay? Otherwise, that time component is crucial. It's not a spend all day on this. And then Friday, we have the rest of it, which will be greatly condensed. Obviously, you don't get 5 of each type of question on the test. All right? You'll have a shorter variety. I'm aiming for something around like 10 questions. I haven't quite finalized my list yet, but it'll be short and sweet because you only have those 40 minutes. Remember, Friday is a little bit shorter to answer. Right? And it'll be online on Google Classroom as a form there. There'll probably be some multiple choice and some free response where you'll actually have to type out your answer. All right? That's the nature of the test. We've covered it so far. As far as what you're allowed to use on the test, you yourself, your brain, your notes, hard copy. Your machine is going to be dedicated to taking the test. I'm going to turn the locked mode on so you can only view the test. You can't switch over to your electronic notes. So if you're relying on electronic notes, make a hard copy between now and then. All right? Print stuff off. Print is fine. Paper handwritten is fine. Okay? You can fill the whole notebook if you want. That's fine. I am writing the test with this in mind, that it will be an open note test. Okay? Hint, hint, that means the questions might actually be a little more difficult. Because I know you have access to those things. They will require you to think, not just, oh, look, there's the answer, write that down. Okay? What else? Not that it's super relevant for our test, but you are allowed up to a graphing calculator or an equivalent So if there is any computation therein, you can freely use a calculator to assist you with that. Again, not there's much for this unit here, but it's there. Other than that, you get nothing else. No asking for help, no talking to other people. You will be on the Zoom call the whole time. Your camera must be on so I can see you are there working by yourself with only those materials provided. Okay? I think that about does it. Are there any questions before we begin about the test itself? I don't have my chat up there. There we go. All right. Then let's run through this review you worked on this weekend. Again, I apologize, I know it was long, but that's the best way to study, is have multiple practices. All right, question 1 was to categorize these math disciplines as pure or applied, straight from that video about the different types of math. So if you pulled that up and you could look at it and go, oh, linear algebra is over on this side, it's in the pure, optimization is on applied, right? And they were all right there. I just went around in the video and said, oh, let's grab that one, that one, that one, okay? Topology, pure. Numerical analysis is applied. Cryptography, applied. Chaos theory, pure. Most of these that say theory on them, that's a hint they're probably going to be a pure field. Group theory, pure. Statistics, applied. Set theory, pure. Computer science, applied. Engineering, very applied. And combinatorics, pure. All right. The next one is taken from another link that we looked at. This is from the Math with Bad Drawings, where it was types of math described in one word. So algebra is relationships, geometry is space, calculus is change, trigonometry is position, probability is uncertainty, statistics is populations, and logic is truth. Okay? Now, this one, possibly more difficult, as I took these from the official Common Core descriptions for the mathematical practices and grabbed the examples themselves are straight from that official documentation there. We did not read, but I hope you could interpret. Some of them are very similar. I totally agree, right? Like looking for and making use of structure and expressing regularity, repeated reasoning. Like it's really similar thinking. So if you had some of them switched up, I can totally understand. If a question from this topic appears on the test, it will not be nearly as cryptic. But there you have the matching elements. Making sense of problems is 5. Reason abstractly is 6. Construct arguments is 2. Modeling is 1. Appropriate tools is 8. Tending to precision is 3. Structure is 7. And repeated reasoning is 6. Sorry, 4. Read that backwards. Okay. Any questions here so far? On Zoom? Okay. All right, and then finally, straight from my set of videos was the Math Thinking Fundamentals. Quantity is size, amount, distance, and measurement. Shape is space and visual representation. Relationships is connecting ideas. Variables is substitution, symbols, abstract, and inverse is working backwards. All right, now for the inductive reasoning, next two terms. Getting some feedback there. Thank you. All right. Unfortunately, the book kind of screwed up when they were printing this, and that they moved the blanks over and kind of covered up the last number a little bit. So some of them are more difficult to tell which is the next one, which is not. So if, for example, on number 3, you didn't quite tell that that was in fact a 1,000, I can totally understand. That's my bad. I didn't look at that carefully enough before I sent it out. But that is a 1,000 there. You can see the O kind of got covered up by the question mark blank before it went in. But the pattern holds nonetheless. 10,000, 100,000. And so far, so this is just multiplying by 10 each time. This one's dropping by 4, right? Constant subtraction. This guy, anybody recognize this pattern? Oh, this is a wonderful sequence. This is the Fibonacci sequence. Right? Very famous sequence, found all over the place in nature. These numbers come up quite a bit. We'll see them again throughout the year. But you are adding the previous two terms. So you take the 1 and the 1 together to make 2. Right? And then the 1 plus the 2 makes 3. And then 2 plus 3 makes 5. It's a really neat pattern there. That one, subtraction. Right. Number 4 is a bit tricky. Look for the common denominator. If you represent all these fractions as a number of sixths, so 6 in the denominator, then you can see we're just counting 1, 2, 3, 4, so many sixths. Triangular numbers, strike again. Square numbers, powers of 2, all very, very common patterns. And then here are my shapes. We've got going up to a 5-sided figure with all the diagonals connected. Got a grid here of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 by, what was it, 10 squares? 10, yeah, I should probably write that down. 7 by 10. Okay, we have the stair steps, the fractal branching, little super duper triforce here going, the Sierpinski's triangle, and this square inside the circles there. And then last one on that page, first blank, using inductive reasoning, you are generalizing from careful observation. When you use deductive reasoning, you're establishing that if a set of properties is accepted as true, something else must be true. Okay, any questions on that page? All right, continuing on then. True or false? For any of the false, you're supposed to fix them, or at least justify, okay, which part of it is false. So number 1, disjunction of P and Q. Disjunction, that's the or, right? Is true whenever P is true and Q is false. So if you have an or and only one of them is true, the whole thing is still true. That checks out. 2, if P then Q is true, then if not P then not Q is true. So notice what they've done there. They've negated both sides, but kept them in the same order. That would be the inverse. It is not necessarily true. That is false. You need the contrapositive, negate and swap the order. Number 3, I am older than 20 or younger than 30 is an example of an exclusive or. You can only be one or the other, not both. That is not true. You can totally be both. In fact, I am both. So that is a false statement. Number 4, the converse, if P then Q, is if Q then P. That's true. And 5, if P then Q means P is necessary for Q. No. Right? If I have P, then I get Q. Doesn't mean P is the only way I can get Q. Doesn't mean it's required for. But it does mean Q is necessary for P. Okay. Questions there? Next section, stating the converse, inverse, and contrapositive of each statement. So in order, we have the converses here. That is where you reverse the order. Inverses, where you negate both sides. So wherever there was not a negation, you put a negation. Where there was a negation, you remove it. And contrapositive, you do both. Negate both and reverse the order. Give you a minute to read through those. Any questions on 6? All right, number 7. True or false? These two equations are both correct. So combined with and, the whole thing is true. This one, if and only if. So both directions have to fulfill the promise of truth renders truth and falsehood leads to whichever. Doesn't matter. 2 plus 5 is 7. That is true. 4 plus 2 equals 8. That is false. So the fact that I can go from true to false, following the arrow, means you're breaking a promise there. So it is false. That is not a biconditional or a true biconditional. One of those will not successfully imply the other. And similarly, C, we have an or. Or is only true when one of them is true, or both of them. 3 times 5 is 12? No. 2 times 6 is 11? No. They're both false. I didn't get anything there. Whole thing's false. D, if 2 plus 3 equals 5, that's true. Then 1 plus 2 equals 4. That is false. You have led me the wrong path. If true, then false. False conditional, broken promise. 3 plus 4 is 6, which it's not. So I started, if something is false, I can conclude whatever I want. Doesn't matter because you didn't break any promises, so the whole thing can be true. If 7 is even, which it's not, same thing applies. I really don't need to read the rest of this. It's true. Starting from a false premise, you can conclude anything, and there's no good way to refute it, except that the first premise is false. You get no meaningful conclusion there. Any questions? All right, next one. They recommend using an Euler diagram. It is not strictly necessary here. But if anyone is interested, say so, and I will happily draw it in for you. But if some men are teachers and Sam Jones is a teacher, to say, therefore, Sam Jones is a man, well, that's invalid. We don't know that you're going the wrong direction here. If they were a man, then you conclude they're a teacher. Maybe. Oh, but that's only some. See, can't really conclude anything from that. Gold is heavy. Nothing but gold will satisfy Amy. Hence, nothing that is light. Well, anything that's light clearly can't be gold because gold is heavy, right? So if it's not gold, it's not going to satisfy her. That's valid. No cats or dogs. All poodles are dogs. So some poodles are not cats. I would say all the poodles are not cats. Would be even better. But yes, that is valid. This does indeed follow from those. Some cows eat hay. All horses eat hay. Only cows and horses eat hay. Frank eats hay. So Frank is a horse. Ooh, so close, right? Only cows and horses eat hay. Lets us conclude if Frank eats hay, then he must be a cow or horse. But we can't get any more specific than that. So that's invalid. And, that's a different type of question. So any questions on 8? All right. 12. Write your own conclusions. All polyhedra have edges. A tetrahedron is a polyhedron. Okay, and ignoring the fancy Greek pluralization, polyhedra is plural of polyhedron. So I hope that didn't throw anybody off, but yes, that means this guy falls into this category, which means it has this property. A tetrahedron has edges. However, if it is 5 p.m., then it is quitting time at work. It is 4:15 p.m. Well, that doesn't tell me anything. I only know information if it's 5. Any other time of day, 4:59 tells me nothing. No valid conclusion there. Because remember, I don't know for certain that that's the only quitting time. Like, well, 4:15, you can't conclude. That means it's not quitting time. You didn't say only. You didn't say only 5 p.m. is quitting time. All right. 14. Coach Schwartz told his starting 5 Wednesday evening, if any of you don't come to practice tomorrow, then you won't play in Friday's game. Darlene is one of Coach Schwartz's starting 5. She came to practice on Thursday. Good job. But she did not play in Friday's game. Did the coach break his word to Darlene? No, he did not. Again, look for that keyword only. Was that the only way to not play in Friday's game? She went to Thursday practice. Maybe afterwards she broke her leg. You don't know. Right? And I've gone one step further here. I said to conclude as such, i.e. to conclude that he broke his promise, going to practice and not playing at Friday's game was valid, would be denying the antecedent. Right? Because you'd be assuming, oh, well, because what you're assuming there is that there exists the true statement, if you do not go to, if you do go to practice Thursday, then you will go to Friday's game. Right? The inverse of what was initially said. That's not always the case. It's not automatically true. Okay. Questions on that one? All right. Finally, here is an argument translated into symbolic form and justify that the argument is valid. When you are justifying that an argument is valid, that means you must provide logical reasons for each statement. That would be, here are my statements, here are my logical reasons that are either it was given to me, or it was a premise I started with, or one of the 4 laws of logic. Those are the only things that can fit in here right now. So, do you have to set it up as a 2-column thing? No. You do have to get this set up. It doesn't have to be these letters. You can use any letters you like. I decided to assign the statement 60 out of 104 majors at the local university require calculus. I called that statement M for majors. I called calculus is an important class to take in college. I called that C for calculus. And the statement high school students should take all the math necessary to enter a calculus class. I called that H for high school. Which letters you used does not matter. Just make sure you're swapping them one for one on your paper. If you see M, but you have a L, then make sure all the M's turn into L's on your page. Okay? So you do need to correctly represent this given was if M, then C. Then they told us if C, then H. And the other given here was just M, right here at the end. In fact, done. Therefore, the conclusion is C. Right? What they didn't state outright was this law of syllogism element. They didn't restate that part. So you have to include that. Say, hey, wait a minute. If you want to get to there, you either have to law of syllogism first, reduce M to C, C to H down to just if M, then C, so that you can modus ponens M and conclude C. Or you do 2 steps of modus ponens. Say, hey, I know M, you told me if M then C, then I can state C by modus ponens all by itself. And then now that I know C, you combine that with if C then H, conclude H by, I wrote C. Why did I write C there? That's supposed to be an H. Oh my gosh, I am so sorry. That's supposed to be an H, that's supposed to be an H. Why did nobody stop me? There we go. Okay. Law of syllogism. Cut out the middleman. If M, then H. There we go. That's what it looks like. And then M, and then conclude that one. See, you mess up one thing in the middle there. Wrote the wrong letter. Yeah, conclusion in red. Red is H. Yes. Okay. This is why sometimes trying to explain your work really helps you find those errors. Like, wait a minute. This doesn't sound right. Okay, did that confuse anybody there? Any other questions there? No. All right. Well, if you don't have any questions for me, then I guess I'm out of things to do for today because that was the last question from the review. Which means you have the remainder of the period. They're about, 15 minutes to study independently? Okay. Or if you have other classwork that needs doing, you may work on that.